Hi everyone, I'm Dave Terr. I'm gonna make another math video, and I'm gonna do a video on location today. Jeez, what a hectic day at work. Now I'm ready to go home and take it easy. Just gotta get on the next elevator. Oh. I don't even know if those elevators are working. It's not moving. Geez, what's going on here? I've been waiting by this elevator for 5 minutes already. The elevator already came by going up. Seems like Murphy's Law, you know, anything that can go wrong will go wrong. So I gotta wait a little longer. When it dings. Oh, here, okay. Well, wouldn't you know it, here's the elevator. Finally ready to go home. I'll see you guys at home. The problem I'd like to answer in this video is, why does the elevator always seem to be going the wrong way? Well, there is a mathematical explanation for what's going on. So let's state the problem precisely. So here's the problem. Suppose we're on the mth floor of an n-story building, waiting to board the next of k elevators that's going down. What's the probability that the next elevator to arrive will be going down? And if there's a tie, then we can take any of the elevators if anyone's going down. So we can call any of those the next elevator. And we have to make some simplifying assumptions, which are going to seem a little strange here, but they don't make the problem. The real life problem is pretty close to having these assumptions. So we have to assume that each elevator stops at each floor and takes the same amount of time to go from one floor to the next. Of course, you wouldn't want to have this in a real building because you don't want every elevator stopping at every floor, if nobody's getting in or out. But don't worry about that for now. It just makes the problem simpler to analyze. And the other assumption we have to make, if there's more than one elevator, every elevator stops at the same instance. So if each elevator stop takes 10 seconds, then you can say that the elevators stop at multiples of 10 seconds on a standard clock or something. So anyway, those are just the assumptions we have to make so that we can solve this problem, basically. And the case of k equals 1, one elevator is the simplest to look at. So let's look at that one first. This is pretty simple. So in the case in which there's just one elevator, what you need to be taking into consideration here is where the elevator is, if it's going to be going down or if it's going to be going up. Well, it's only going to be going down if it's already above you, right? Because remember, it's stopping at every floor. It has to stop at your floor. So if it was below you when it arrives, it's going to be going up. And if it's above you when it arrives, it's going down. So I think you can kind of see now why the probability is not equal, that the next the next elevator is going to be going up or down. Because if you're near the top of the building, clearly there's fewer floors above you. So the probability should be less that the next elevator is going down and more that it's going up. So it's not just Murphy's Law. There's actually a mathematical explanation. Uh, and you can be precise about this. I mean, the way the floors are marked in American buildings, I think it's different in Europe. I think in Europe they call the ground floor floor 0. In America, we call it floor 1. It actually makes more sense to count starting with 0. So I think they do things better in Europe. But here we do everything the wrong way. So we start our floors at floor 1. So, it's easy to see in this case that there's n minus 1 floors going up and another n minus 1 going down. So there's 2 times n minus 1 total stops of the elevator. And how many of those stops are above you? Well, exactly 2 times n minus m. So the probability that the next elevator is going down is going to be the ratio, 2 times n minus n over 2 times n minus 1. Well, you can cancel the 2's and you get n minus m over n minus 1. And you can do a very similar analysis for the elevators going up if you want to go up instead of down. There's 2 ways you can get that. Either you do the other analysis for the case in which the elevator's below you, or You can simply note that these probabilities have to add up to 1 because the elevator is either going to be going up or down. However you do it, the answer you get for the next probability the next elevator is going up is m minus 1 over n minus 1. And just to be specific here, to give you a specific example, suppose the building has 50 stories and you're on the 40th floor. So you're near the top. And then in that case, you can just apply the formula and then when you do that, you see that the probability that the next elevator is going to be going down is 10 over 49 or approximately 0.204 or 20.4% if you like, a little over 20%. So clearly that's less than one half. That means there's only about 1 in 5 chance that the next elevator to ride is going to be going down. It's much more likely to be going up. So it's not just Murphy's Law. I mean, if you like, you can think of it as a case of Murphy's Law, but there's a mathematical reason for it. So anyway, that's how this works. And you might be wondering what happens if you have more than one elevator. Well, I actually did this calculation a few weeks ago. The analysis becomes much, much more complicated. I'm not going to do it here, but I'll just present the formula. So these are the formulas you get in the case in which k is greater than 1. I guess these formulas also work if k equals 1, but these are the general formulas. So the probability the next elevator is going down if there's n floors and you're on the mth floor and there's k elevators. Is this quantity is kind of an ugly expression, but it's 1/2 times the quantity 1 minus the quantity n minus 2m minus 1 over n minus 1 all raised to the kth power. And you get a very similar equation for the probability the next elevator is going up. And I think it's easy to see that these probabilities add up to 1 as they need to. It's also pretty easy to see that the probability still, with however many elevators you have, if m is greater than n over 2, in other words, if you're on one of the top floors of the building, the probability that the next elevator is going down is less than 1/2. And that you can think of that as a case of Murphy's Law because you're probably going to be wanting to go down. But if you were near the bottom, if you were on one of the bottom floors, the probability is greater than 1/2 that it's going down. The general thumb is that if you're the elevator is more likely to be going in the direction you don't want to go. It's going to be going in the easy direction. So if you're near the bottom of the building, the next elevator is probably going to be going down. If you're near the top of the building, the next elevator is probably going to be going up. But you should notice something interesting about these formulas. Notice that the quantity in parentheses in both terms is raised to the kth power. So what happens when k grows, if k gets large? Say you have 100 elevators. Now, of course, you're never going to have that many, but you're raising a quantity that's strictly between 0 and 1 in these parentheses. You're raising that to a large power. And you know that whenever you raise a number that's less than 1, to a large power, it gets very, very small. So as k goes to infinity, what that means is these probabilities do approach 1/2. So if you want it to be equally likely that the next elevator is going up or down, all you have to do is just have a whole bunch of elevators. But of course, the people who made the building probably didn't want to spend too much money on elevators. So I think the most you'll ever see is around 6 or so. Even with k equals 6, these probabilities are pretty close to 1/2. So I guess the upshot of all this is if you don't want to wait too long for an elevator, you just have to have a lot of elevators, and the next one arrive is not going to be all that unlikely to be going down or in the direction you want it to be going. So anyway, that kind of relieves Murphy's law a bit in this case. But anyway, that's my video. I hope you enjoyed it. Thank you for watching. Long live math. And don't get stuck waiting for the elevator too long. And I hope you guys enjoy your Memorial Day weekend. And I'll see you guys next time. Bye.